Hey there everyone, Mr. Lewis here, ready to walk through section 4.2 of Unit 4 today in AP Micro, Imperfect Competition. And today's focus is on the monopoly, something that you might have a little bit of background knowledge about. So the term monopoly has been made famous in pop culture because of the board game. And the board game is actually a representation of the technical monopoly that we're going to discuss today. So in the board game Monopoly, the whole purpose is for you to own property. And that way, if people move around the board and land on your property, they got to pay you rent most of the time. So the whole point is if you own all of the properties on that board, you have a monopoly on property, and people literally can't even play the game without landing on your property at some point and paying you. So you are the only producer of property in the game, right? Well, that's the idea of a monopoly. In a monopoly, it's a market structure where one firm has complete dominance. They have 100% market share or 100% market power. All of the consumption in that market goes to them. They're the only producer because they have a completely unique product. This results from high barriers to entry. So it could be high startup costs that are keeping companies from getting into the market, such as the satellite radio industry. Sirius XM Radio has a monopoly on satellite radio, not because they're necessarily the only ones who can do it well. They're the ones who got an early start on it. And actually, Sirius and XM used to be two separate satellite radio companies, but they were both losing money, so they decided to merge. This is a situation where, because of the high startup costs associated with being a satellite radio company, there aren't many firms who are looking to enter that market and try to compete. So it results in a monopoly. Another type of monopoly results from patents or legal protection, right? So these legal barriers to entry could be like patents, trademarks, copyright, things that do not allow other firms to even produce that product legally. One example of this is EpiPens, and the company that makes EpiPen has a patent on them, and it's something really important because people who have allergic reactions have to have these EpiPens around just in case, and in many cases, they are life-saving. So for a company to have a monopoly on a good like that is pretty interesting, and it raises a lot of questions about what type of regulation they should face from the government, if any. And there are many debates about that, but that's not what we're getting into today. Today, our focus is on the graph for a monopoly, and actually, it's very similar to perfect competition. We've got two graphs here at the bottom. The one on the left is an individual firm operating in perfect competition, which we saw last unit, and the firm on the right is a monopoly. And as you can see, they're exactly the same for right now. The reason for that is the cost curves for an individual firm in perfect competition or for a monopoly are the same. The only two curves we have up here right now are marginal cost and average cost. And that marginal cost curve always takes on that J shape. The average cost curve takes on this U shape. And just as a quick reminder, the reason for this is the marginal cost starts higher because it costs us a lot of money just to get the business up and running. So initially, marginal costs are high. Then we get much more efficient, and that marginal cost reaches a low point. Eventually, it swoops back up because we hit diminishing returns. So as soon as diminishing returns kick in, marginal cost starts to increase. Now, if marginal cost is lower than average, then the average will continue to come down. But as soon as marginal cost rises above the average, that's like your semester GPA passing up your cumulative GPA. Well, if your semester GPA is higher than your cumulative, then your overall cumulative or your overall average GPA will also increase for the time being. So marginal cost and ATC always take on sort of this trident formation where the marginal cost goes through the very bottom point of the ATC curve. So for both types of firms, these look exactly the same. The difference comes in when we graph our demand curve. For an individual firm in perfect competition, remember the demand curve is just perfectly elastic. It's a perfectly flat, horizontal curve because the price is being determined in the market and the individual firm is a price taker. They're just taking that price and charging that price consistently. So that becomes their demand curve, and actually it's also their marginal revenue curve. For a monopoly, though, they're a price setter. They can move the price. They're the only ones who sell this thing. So because of that, they are subject to the law of demand. As price decreases, they get more customers. As price increases, they're going to get less customers. So we wind up with this negatively sloped demand curve. Now, this is just demand. It's not also marginal revenue. Marginal revenue is a product of demand, right? Really, it's a product of price. So because a monopoly has to constantly decrease their price, you can see that in this chart over here. Let's say they're decreasing it from 10 to 8 to 6 to $4 to get more customers. They will, in fact, increase their quantity sold 10, 20, 30. But as they do that, you can see that marginal revenue starts at the same place as price. But as we continue to decrease our price in order to get more customers, marginal revenue is going to continue to decrease at a faster pace than the demand curve. Consequently, we end up with a negatively sloped demand curve that starts at the same point as, negatively sloped marginal revenue curve that starts at the same point as the demand curve, but it starts to separate more and more and more and more. They're constantly diverging as we move toward the x-axis. And that's it. Those are our four curves that we need for a monopoly graph. And as you can see, it's really not that much different from perfect competition. The big difference comes in with our demand curve. But before that, they were exactly the same. Once we graph that demand curve, in the case of individual firm and perfect competition, it was also the marginal revenue curve. So we only needed one curve for both items. With a monopoly, we need two separate curves, but that is what they are almost always going to look like. So we've got our graph, we've got our marginal cost, average cost, demand, marginal revenue, the same four items that we needed in perfect competition. Now we need to find our output and our price and our profit and all those things that we can sort of extract from this graph. So a monopoly is still maximizing profit. They're still going to follow that marginal principle, just like an individual firm in competition, perfect competition. The difference is a monopoly in the long run, they might actually earn profit. They could also incur losses, though. That's very important to understand. There's no guarantee in the long run for a monopoly. And that was actually in this chart from the end of section 4.1. It says long run profit down here in this row. For a monopoly, it says possible. It doesn't say guaranteed. It's possible. For perfect competition and monopolistic competition, there's none. For an oligopoly, it's possible. But for a monopoly, it is simply possible as well. It's not guaranteed by any means. And a lot of monopolies actually lose money, and that's why they're a monopoly. They're betting that in the long run, they'll be the only ones left and they'll end up making a lot of money. But other firms are like, no, we're not going to sit here in the short run and lose a bunch of money. You guys can, have the market all to yourselves or something along those lines. So let's determine the output. If it's simply the marginal principle, that makes it pretty easy, right? MR equals MC. That's our marginal principle. So find the point where the marginal cost curve here, our J, takes on or intersects with the marginal revenue curve, the light green one. That happens here. And what do you know? That is exactly where we are going to plot our profit maximizing quantity, Q sub PM, for this particular monopoly. Now let's move on to price. In perfect competition, this was a little easier because the price was simply taken directly from the market and the demand curve also represented the price, right? It was one flat line. But that last little thing I said there is very important. The demand curve does determine the price for us. So Think about how a demand curve is actually graphed. It's two variables, right? On the y-axis, it's price. On the x-axis, it's quantity. Well, we just figured out one of those two variables. We figured out this quantity. We know this is how much we want to produce because that's our profit maximizing quantity. If we produce beyond that point, marginal cost is still going upward, but marginal revenue is going downward. So we're going to lose money, marginally speaking, on the very next unit we sell. We want to stop here to make sure we capture all of that economic profit before we start losing some of it. So if we already have our X value, all we have to do is follow this value up to the demand curve and then go over. And we can plot our profit maximizing price on the y-axis. So that would be our price, that would be our quantity. The last thing we need to do is calculate profit. And for profit, we know that our formula is this, price minus ATC times quantity. Well, again, here's three variables, right? We have price, we have quantity. We're in another situation where we just need to find one more variable to make this all work. So we're putting the pieces together. First we found output, then we found our price. Now we just need to find our average cost. Well, just like in perfect competition, we're simply going to go down from the demand curve to the average total cost curve. And I'm only using this particular dotted line because this is the output that we're producing. We already stated that. We already decided this is how much we're producing. So all that matters is what falls on this particular X value or this quantity. So here's my price at the demand curve. If I go down from that curve, here is where the ATC runs through this particular X value. So this is my per unit profit, price minus ATC. And you can see that that's also measured over here with these 2 points. Here's my price. This would be average cost. So price minus ATC times quantity. This entire area would represent economic profit. So you just have to find those three things, right? Quantity, then price, and then just look for your average total cost curve. Now, because a monopoly has market power and they're doing what's best for themselves, they're not thinking about what's best for society necessarily, right? They end up creating a deadweight loss. In perfect competition, we didn't have to worry about this because it was perfect. Everything was great. It was a perfectly competitive market. But in this case, the monopoly is actually skewing things a bit. So there's two key points you need to take away from today on this graph. One is the profit maximizing point, which we just found. The other is what we call the socially optimal point. And we've learned about that before. This is allocative efficiency, right? Socially optimal. That occurs where price is equal to marginal cost. That is the case in perfect competition. The price is equal to marginal cost. If you think about it, on a perfectly competitive graph, this is our equilibrium, right? Where the demand curve, which is also the marginal revenue curve, intersects with the marginal cost curve. So at that point, everything is equal. The price, marginal revenue, marginal cost, and at the long run, average cost as well. But for a monopoly and every other type of firm in any other market structure, check out this bottom row here. It says price and marginal cost. It's talking about the relationship. In perfect competition, they're equal. In every other type of market structure, price is greater than marginal cost. What that means is that they are not achieving allocative efficiency. Perfect competition does. It naturally creates allocative efficiency. It is naturally socially optimal. That is not the case with any other type of market structure, specifically today, a monopoly. So here's what happens as a result. This point where the marginal cost curve hits the demand curve is our socially optimal point. So that is our socially optimal quantity, QSO I've labeled it, and this is our profit maximizing quantity in green, QPM. So there's a gap between what the market wants, what society wants in red, and what the monopoly is actually choosing to produce, which is their profit maximizing quantity. The difference between those two things is the dead weight loss, what we want versus what exists, right? So our dead weight loss takes on this shape in this area. The gap between QPM and QSO, it's this area here. So this would be, this red equilibrium, that would be the equilibrium if this were a competitive market. Where the marginal cost curve hits the demand curve, that would be the competitive equilibrium. But instead, the monopoly is imperfect, right? It's not a perfectly competitive market. So instead, they're not producing at the competitive equilibrium. They're producing where they want to, what's best for them, where marginal cost hits marginal revenue. And that's not the same point. So because there's that gap, it creates dead weight loss. We could also measure consumer surplus on a monopoly graph. And it's the same way we would on any other graph. Consumer surplus is everything above the market price. So all of these consumers on the demand curve, from here to here to here, all the way up to this corner, they're all willing to pay more than this current price. So this consumer earns this much surplus. This consumer, this much, right? It's willingness to pay minus price. So this entire area is filled up, and that becomes our consumer surplus. So this is what a profitable monopoly looks like. Let's take a look at a loss incurring monopoly. It's all about the ATC curve. So in this case, the ATC curve is way up high, right? Here, it was down low. So the only difference between these two graphs, as I keep moving back and forth here and probably driving you nuts, but the only difference between these two graphs is that ATC curve, as you can probably see. Now, how would we graph this? Same as always. The quantity and price don't change, because what determines quantity and price is the marginal principle, where MR intersects with MC. Marginal cost, marginal revenue, here, right? That's not changing from one graph to the next. The only thing that's changing is that our average cost curve now is above the price. So we're producing at this quantity and we're charging this price, but the ATC curve is up here. So this gap, you can see the cursor moving from this point to this point, that's representing our per unit loss. And because of that, we are incurring a total economic loss of this red area. Price to average cost times quantity. So you could also think of it as up here is ATC. So this would be average cost minus price times quantity. This is giving you the total area of economic loss. So, like I said, the price as a result, if we have a profit earning monopolist or even a loss incurring monopolist, the price is going to be greater than the marginal cost, right? When we look at the results here, this yellow sort of equilibrium, that's where our marginal principle is true. That's where MR and MC sit, but price is way up here. So price is greater than marginal cost. That creates dead weight loss in red. We could also calculate total revenue on this particular graph because total revenue is just price times quantity. So we have price and we have quantity. We could also calculate total cost because we know that ATC runs through our quantity here. So ATC times Q would be total cost. And then, of course, the little bit of revenue that's left over here after we subtract all this cost would simply be profit. The last bit here is what we call a natural monopoly. A natural monopoly, quite simply, is a monopoly in which the long run average cost curve, which you can see here on top, LRAC, is constantly downward sloping. It is constantly decreasing, and that means that the firm has constant economies of scale. And this is a unique situation. You can read a little bit more about it right here. This is a unique situation where economies of scale are always in effect, but this is what we call a natural monopoly. If you're ever faced with one of these, don't treat it any differently than you would a regular monopoly. Okay, the profit maximizing output is still going to be the marginal principle, where MR equals MC. So here's long run marginal cost, MC, here's MR, those two curves hit here. The profit maximizing output would be Q1. The profit maximizing price, we would go back up to the demand curve and over, it would be P1. The profit for this firm would be price minus average cost times quantity. So this whole area here, this rectangular area, would be economic